Hello, my name is Doug May, and I'm a research professor at Memorial University in Newfoundland and Labrador. There's been a lot of discussion in the province about the MOU between Hydro Quebec and Newfoundland and Labrador Hydro. And a lot of the discussion has taken the perspective of what it means to Newfoundlanders and Labradorians. And that's important. But I want to take a different approach. What I'd like to do is take the Quebec perspective. In other words, what does it mean really to people in Quebec and to the industrial strategies which the Quebec government adopts? So I want to concentrate on that. I should say at the very beginning, looking at the title, that Quebec takes the perspective that it's the green energy powerhouse of North America. Will it continue to be that way? Is it that way now? Where are we? And so I'm going to start this series, this very short series, by focusing in on production. What we're going to focus on is turbine electricity generation by Hydro Quebec, by the utility. And the period of time we're going to be looking at is between January of 2015 to February of 2025, so quite recently. And the data that we're using is from Statistics Canada. And we're going to look at monthly data, and we're going to look at the number of megawatt hours of electricity produced every month by this Quebec utility. So when you look at this, you see a particular pattern, and the pattern which you'll see is that it is highest in January, and then it goes down, and then you see a little bump in July. So January is the coldest month. They use a lot more electricity then. And then you'll use more electricity in July, presumably due to air conditioning, right? So the pattern looks fairly constant, except for one thing that happened back starting around here, 2023. This is January 2023. Where we see there is a fair drop in the amount of electricity which was being produced. So you can see it probably better at the bottom here. It's going from down. Whether they'll still continue into this year, 2025, remains, of course, to be seen. The point here is that supply rises to meet its own demand. So you can think of it in terms of hydro generation, turbine generation of electricity. There's a big reservoir, and they let so much water go over the dam. But the reservoir can be thought of as a big storage battery. And as you need more power, then you can let more water through. That's what happens. So it's not necessarily that you have higher rainfall here, it's that you just let more water through. But if you let water through here, then you may not have the water down here. And the fact that we've got this declining amount here is due to a drought in Quebec, in northern Quebec, which meant that there was less water to go through the reservoir. So you have to be a bit strategic. So what are the 3 points which we should take away from this? One, that electricity demand is seasonal, rises in January, the coldest month, falls, rises a bit in July. Secondly, supply must meet peak load demand. So when you're thinking about the capacity of electricity that you put out there, then you'll have it, you've got to meet the peak load demand. Otherwise, if you don't, people are going to freeze in the winter and they'll die from heat exhaustion in the summer. You've got to have the capacity in there to meet the peak, even though when you look at the amount of electricity generated over the year, the average amount will be well, in the case of Churchill Falls, it has historically been about 72% of capacity. Why don't you run at 100% capacity? Because demand doesn't have these peaks. The other point, which is obvious here, the third point, which is domestic supply of electricity from hydro, depends on water supply. And this can be affected by climate change, which is exactly what we saw in the case which we're dealing with in Quebec and northern Quebec. So the big question there is, in fact, is this climate change, is it a one-off feature, or is it really climate change, and how will it impact the amount of electricity? The other thing which we don't see there is that we've seen peak load demand and trying to meet that, but demand, because of technological change, because of population growth, because of lifestyle changes that we want better controlled climate, maybe more people can afford air conditioning, then what we're going to see is that demand is constantly increasing for electricity because of such things as, I say, AI, and population increase. So, and supply also has to increase, but can supply from hydroelectricity increase? So that's enough of a focus on production. Thanks for watching.